In our Shapes Toolkit, we have a space for the definition and we have a space for property. So the definition of a shape is basically the bare minimum amount of information you need to show that this is that type of shape. There are also special properties that occur with a bunch of shapes. So as I'm going through these, you're going to notice that I have things written in different colors. I have the definitions written out in red, and the markings on the diagram are also in red, and that's for the definition of the shape. But then I also have any special properties that the shape has written out in blue and then marked in the diagram in blue. So that's what those different colors mean. If a shape doesn't have any special properties, then I just have the diagram written out in green. Now, before we start going, I want to show you a couple symbols. So we have these special symbols in geometry, and you can use them to replace words as you're writing stuff out, and it'll just make it a little bit easier for you to write. So the first symbol that I'm going to show you is our symbol right here. It looks like an equal sign with a little squiggle on top, and that means congruent. And things are congruent in geometry if they have an equal length or an equal measure. So congruent is just another way of saying equal. And you can use this symbol right here for that. These two parallel lines, which kind of look like a slanted 11, that means parallel. So if you ever see those markings, that just means the two things in between them are parallel. All right, so let's start with equilateral triangle. An equilateral triangle, the definition is a triangle with 3 congruent sides and 3 congruent angles. So you can see on my diagram here, I have the sides marked with tick marks and the angles marked with tick marks. So all 3 sides and all 3 angles are equal in an equilateral triangle. An isosceles triangle, the word isosceles means that you have 2 congruent sides. So the definition of an isosceles triangle is that 2 of the sides are equal or congruent, but it also has this special property that the base angles are also congruent. And the base angles are the angles that are across from the equal sides. So that's an isosceles triangle. Now let's take a look at an isosceles right triangle. It's isosceles because it has 2 equal sides, and it is right because it has one 90-degree angle. So that's the definition of the isosceles right triangle. But just like the isosceles triangle, it has the property that the base angles are also congruent. So I have those base angles marked as being congruent as well. All right, the next one we have is our square. A square is a quadrilateral, so that means it has 4 sides, and it has 4 right angles, and all 4 sides are congruent. So as you can see, I've got the markings for the 4 right angles. I have the tick marks for the 4 congruent sides. But then a property of a square is that the opposite sides are parallel. So I've got my little arrows or my carets to show that the opposite sides are parallel. Just a reminder, you don't need to be writing this all down as I'm going, because I'm going to go kind of quickly and you may not have time to write it all down, but it's all in the Pear Deck for you later if you need to look at it. All right, next we have a scalene triangle. Remember, the word scalene means that all 3 sides are different lengths. So you might see markings like this where all 3 sides have different tick marks. That tells you that it's scalene. Or if they're not marked at all, that means that it's scalene. So it's a triangle where all 3 sides have different lengths. If I have a scalene right triangle, that means that all 3 sides are different lengths and it has 1 right angle. Next up, we have the rectangle. Oops, let me do this. Rectangle. A rectangle is a quadrilateral, so 4 sides, and it has 4 right angles. So you can see right here, I've got my little squares marked. That is the definition of the rectangle. But what we also know about a rectangle is that the opposite sides are congruent and parallel. So you can see I have the tick markings here to show that the opposite sides are equal to each other. They're congruent to each other. And then I have the carets or the arrows to show that the lines are parallel. The opposite sides are parallel. And then finally on here, we have parallelogram. The definition of a parallelogram is it's a quadrilateral with 2 pairs of parallel sides. So the opposite sides are parallel in a parallelogram. What we know about parallelograms is the opposite sides are also congruent and the opposite angles are congruent. So it's starting to get a little crowded in that parallelogram there, but I do have all of the tick marks for the opposite sides being congruent and the opposite angles being congruent. Next up, we have trapezoid. A trapezoid is a quadrilateral with one pair of parallel sides. So you can see I've got the arrows here showing that those sides are parallel. Next up, we have the rhombus. Oops, some of my tick marks went away. We'll fix that. A rhombus is a quadrilateral with four congruent sides. So I've got my four sides all marked with one tick mark. And then we learned that a rhombus, the opposite sides are parallel. So you can take a look there and see that I've got my opposite sides marked as being parallel. Okay, another quick vocabulary word for you before we go into these next definitions. The word regular in geometry. Regular doesn't mean just like usual or like the one you're used to seeing. Regular has a very specific definition in geometry. It means that the angles are congruent and the sides are congruent. So it has congruent sides. It is equilateral. Equilateral means equal sides. And it has congruent angles. It is equiangular. Equiangular means equal angles. So first up, we have the regular pentagon. Pentagon, penta means 5. So regular pentagon has 5 congruent sides and 5 congruent angles, but no other special properties. So you can see my tick marks there on my pentagon. All 5 sides are equal and all 5 angles are equal. Next up here, we have the regular hexagon. Hexa means 6. So you can see here it has 6 congruent sides and 6 congruent angles. My diagram was getting a little too crowded though, so I didn't mark the properties, but for a hexagon, it has 3 pairs of parallel sides. So the opposite sides of a hexagon will be parallel, but I just didn't mark them on that diagram. Next up, we have a right trapezoid. So a right trapezoid has 1 set of parallel sides and 2 right angles, and it's a quadrilateral, so that means it has 4 sides. So 1 pair of sides is parallel, and it's got 1 pair of right angles. Kite. A kite is a quadrilateral with 2 pairs of adjacent congruent sides. The word adjacent in geometry means next to. So the congruent sides are next to each other, not across from each other. So there's 1 pair of congruent sides and here's the other pair of congruent sides. And the property of a kite is that the angle between the non-congruent sides is congruent. So it's got 1 pair of congruent angles. And those are marked up there in blue in the diagram. Oh, we're almost done here. We've got the isosceles trapezoid. It is a trapezoid with congruent base angles. And it actually has 2 pairs of base angles. The angles up here at the top and the angles down there at the bottom. Those 2 pairs of base angles are congruent pairs. And it is a trapezoid, which means it has 1 set of parallel sides. The property of a isosceles trapezoid is that the non-parallel sides are congruent, and that's what those tick marks mean. So there's our isosceles trapezoid. And last but not least, we have the circle. A circle has a center, and basically a circle is every single point that's the same distance from that center. And that distance is what we call a radius. We're going to learn about circles next semester. But the interesting thing about a circle is it's not actually a polygon. It is just a set of points. It's every single point that's that same distance from that center point. So there are all the shapes on your Shapes Toolkit.